Okay, looking at 7.4, we're going to be looking at parallelograms still, but we're going to be talking about some different special cases of parallelograms, just some properties of specific types of parallelograms. So we have one branch of parallelograms up at the top. It's like an umbrella. And then we go underneath it and we have rectangles, rhombuses, and squares. And we're going to be looking at all their different properties. So if we look here at this one, we have rhombuses, rectangles, and squares all listed out. So a rhombus is a parallelogram that has four congruent sides. Okay, parallelogram, remember we have two sets of parallel sides. And so all four of those sides, they'll have to be congruent to be a parallelogram. Then we have a rectangle. It's a parallelogram with four right angles. And then a square combines both of those. It's going to be a parallelogram with four congruent sides and four right angles. It combines both the concepts of a rhombus and a rectangle into one. And so if you look here at this Venn diagram, this is a good little tool. And in the next lesson, when we kind of close up this chapter, we'll have more being able to look at quadrilateral specifically. But here we have just parallelograms, and it shows on the outside of our Venn diagram, we have types of parallelograms that are just parallelograms. And then we have the Venn diagram inside it. So we have our rhombuses on one side, we have our rectangles on the other side, and then like I said, squares combine both of those concepts. So square is both a rhombus and it is a rectangle. It falls under both categories. So in example 1, it tells us we have a rhombus of QRST, and it wants us to decide whether the statement is always or sometimes true. Okay, so we're talking about a rhombus. I'm going to have four congruent sides. Okay, and one thing to remember is when it lists the letters, that means you're going to go around that shape in that order. So I went from Q to R to S to T. Okay, make sure you go in order. I can't put R across from Q and all that stuff. It has to go in order. So it tells me that Q is going to be congruent with angle S. So think about it. Would that always be true or would it sometimes be true? Well, think about, we're talking about a parallelogram. If we're talking about a rhombus is a parallelogram. And in parallelograms, Q and S are opposite of each other, and opposite angles are always congruent. So this one would be always. If we look at the next one, it tells us that Q is congruent with R. Okay? Q and R are right next to each other. Okay, so they're consecutive angles. But it doesn't necessarily mean that they would never be congruent. Q and R are next to each other, so that means we know in a parallelogram they're going to be supplementary. But just because it's a rhombus, they could sometimes be congruent because a square is a rhombus, and in a square, Q and R would both be 90 degrees, and so that would make them equal. So this one would be sometimes. Okay, so in a rhombus, sometimes the consecutive angles can be congruent, but because they are parallelograms, opposite angles are always congruent. And so briefly, if we look at this example 2, it wants us to classify this quadrilateral. So if we look at it, it has four sets of congruent sides. And then it tells us one angle is 70 degrees. What it doesn't tell us is if the sides are parallel or not. Okay, but one thing that if you will want to look in your book and stuff like that, with rhombuses, if the sides are congruent, if all four sides are the same, that means that those lines are going to be the same distance apart, and they're going to be this on every single side, and so it will follow that those sides have to be parallel with each other. Okay, simply for the fact because as we kind of just turn this shape, as we kind of move, if we were to move this side only, it's going to stay parallel with that other side because they're the same distance apart no matter what. So our reasoning in this, we're going to have rhombus. It is a rhombus because we have four sets of congruent sides. It is not a square because it doesn't have 90 degrees. But like I said, it's a rhombus because it has four sets of congruent sides. And so we can automatically say it's going to be a rhombus. It's not a square, but it is a rhombus. Then we have some theorems that come along with a rhombus. We have diagonals theorem. So think about in a parallelogram, we know diagonals bisect each other. Okay, but in a rhombus, diagonals not only bisect each other, but they also have to be perpendicular. Okay, in order for it to be a rhombus, those diagonals are always going to be perpendicular to each other. So they're going to meet at those right angles. And then we have opposite angles theorem. A parallelogram is a rhombus if and only if its diagonals bisect the pair of opposite angles. So not only do those diagonals bisect each other, but they're going to be angle bisectors as well. And so as you can see here, we have these one line ones here. So it's showing us that it bisected angle A, it bisects angle C, etc. So if we look here in example 3, we are told that this one's a rhombus because it says finding angle measures in a rhombus, so it's telling me that ABCD is a rhombus. And so we have here that 61 is the only angle that we have. Okay, but think about what we just said. We said the first theorem, rhombus diagonals meet at a perpendicular. They're going to be perpendicular to each other, so that means they meet at right angles. So first, this angle 1 here in the middle, it's on the place where those diagonals meet, so that means it's going to be a right angle. So the measure of angle 1 is 90 degrees. Okay, easy start there. Then we also said that they bisect the angles. Okay, so my diagonals are cutting all those angles in half. So if this side is 61, that means this side has to be as well. So that gives me both those angles would be 61. Then if we go across the way, okay, remember in a parallelogram, opposite angles are congruent. And so because those opposite angles A and C are congruent with each other and they're being both bisected, that would mean that both of these have to be 61 degrees as well. So we have measure of angle 2 is 61, and we would have measure of angle 3 is 61. Then the last part comes down once again to our quadrilaterals and being able to find those angles, those interior angles. So our sum interior angles theorem, okay, we know that it is 180 times n minus 2. Okay, this is the formula that's going to keep coming up in this chapter. 180 times n minus 2 gives me the interior sums. So 180, we have 4 sides. So we keep working it. We have 180 times 2 here. And so it gives me 360. Quadrilaterals always have an interior sum of 360 degrees. So if we take away from that the angles that we already have, we would have 360 minus, we have 4 angles of 61 degrees, right? We have these two here, this one, and then 3 and 2 as well. We have 4 61-degree angles already in the interior. We don't count the 90 degree in the middle because it's not on the angles on the inside of our shape. That's just from the diagonals. And so we do 460 times minus 4 times 61. Sorry, 360 minus 4 times 61. Well, 4 times 61 gives us 244. So we would get 360 minus 244. And so that gives us 116. And so now that 116 is what's going to be for both these angles, for D and for B. Okay, that 116 is across all of those. But B and D are also bisected into 4 angles, actually. So that would mean I need to divide that 116 by my 4 different parts. Okay, because all those parts are going to be congruent. So if I divide by 4, that's going to give me 29 degrees. So each of these sides would be 29. And just a check, if you were to add all those up, it would give you your 360 for your quadrilateral. If I were to add the 3 angles up inside this triangle here, too, this would also give me 180 because the triangle has 180 degrees. So if I did 29 plus 61, that gives me 90 plus my 90 from my diagonals intersecting at right angles. I get 180. That's just kind of a check to be thinking about. So for the last one, for measure angle 4, I got 29 degrees. And so as we continue to move forward, I mean, this has been this whole course, but we're going to keep having just more and more theorems. So I encourage you, make sure you write them down. Make sure you're doing all the practices and all the activities. The more that you do it, the more it's going to be in your memory. So when we do rectangle diagonals theorem, this tells us when we have a rectangle, so remember rectangles are parallelograms that have 4 right angles, then it tells us our diagonals in that parallelogram of a rectangle are going to be congruent with each other. So if we look at example 4, we want to identify a rectangle. It tells us we're building a frame for a window. The window will be installed in the opening shown in the diagram. They are wanting the opening to be a rectangle. So it says, given the measurements, can you assume that it is a rectangle? So in the first one, A, just given the side measurements, does it tell us that that has to be a rectangle? My answer for this would be no, because just because I know the side lengths, yes, we know the opposite sides are equal here, that only tells me that it is a parallelogram. Okay, I do not have anything that tells me that it is actually a rectangle, because if it would be a rectangle, I need those right angles or I need more information. If we look at B next, B tells us that we measure the diagonals of the opening, and it tells us the diagonals are 54.8 and 55.3. They're close, but they're not the same. So again, it says, what can you conclude about the shape? The conclusion would still be that it's not a rectangle, because if you look at the one we just looked at, it tells us diagonals are congruent in a rectangle. So in that case, it's just a little bit off. Like say this one was the 54.8, and then going the other way, we have the 55.3. That means that this one's just going to be a little bit more closer in, and so it's going to be slanted a little bit. It's not going to be a true rectangle. And so in this last problem we look at, we have rectangle QRST, and it tells us that QS, so that's one of our diagonals here, is our 5x minus 31, and RT is 2x plus 11. So it says find the lengths of the actual diagonals. Okay, well we said because it's a rectangle, diagonals are equal, so I'm going to set these to be equal. And then I just have to solve. So to solve, I'm going to subtract my 2x. And I had somebody the other day say that they weren't sure how to start on solving these. It doesn't matter. If you wanted to subtract 5x and move your x to the right, you should get the same answer. Okay? Just start trying to get same terms together until you're left with your x by itself. So then here I'm going to add my 31 because I already have my x's on one side, so I'm going to try to move my constants to the right. So I get 3x is equal to 42. And so then I need to get x by itself. I'm going to divide by 3. And so when I divide by 3, I get x is equal to 14. It wants, though, it does not ask for x in my problem. It says, what are the lengths of the diagonals? So I'm going to take this 14, and I'm going to plug it back in. So I get 2 times 14 plus 11 if I do that one. So 2 times 14 gives me 28 plus 11. It's going to give me 39. If I were to plug it into the other one, I would get the same answer because the diagonals are equal to each other. So my answer would just be 39.